Hi! Today we're going to learn about a common problem to use integration by parts on. Let's say we have to compute the integral of x squared e to the x dx. So how do we compute this? Well, just looking at this, we can see that it's screaming for us to use integration by parts. How do we know that? Well, we know, first off, that this integral has two factors. The first one is x squared, and the second one is e to the x. The second thing that screams at us, or the second reason why we should use integration by parts, or the second factor of that, is that one of these is repetitive, when we take the derivative. So we know that the derivative, or in this case, the integral of e to the x will be e to the x. With sine and cosine, it's a similar thing going on. We know that the integral of sine of x would be negative cosine of x, but the integral of negative cosine of x is negative sine of x, and as you can see, that's a cycle. So we use integration by parts when we have this algebraic function x squared, so we're decreasing this until we get to a constant with no more x in the algebraic section, and the other term, or the other factor, has to be one that continues in a repetitive cycle. So let's see if that holds true for this problem. So, when we do our integration by parts, our u has to be the algebraic function, or the function that decreases until it's gone, and just left with a constant will have to be, and in this case it'll have to be x squared. The dv, or the repetitive cycle function, would be, in this case, e to the x. So du would be equal to 2x dx, and v would be equal to, this is dx, and v would be equal to e to the x. So we do integration by parts to get that this integral will be equal to the integral, or sorry, not this. This integral would be equal to uv, which is x squared times e to the x, minus the integral of 2x e to the x dx. Once again, we have to use integration by parts another time. And one way that we know when we have how many times we have to use integration by parts is if we just have a problem like this that continues in the repetitive cycle, we have to use integration by parts until this exponent becomes 1. Until this exponent becomes 0, or 1. So let me explain how that works. So in this case, it takes 2 cycles for this exponent to become 0. So that means that we do integration by parts twice. So basically, whatever number the exponent is how many times we have to apply integration by parts. So we applied it the first time. Now let's see if that holds true and we're finished the second time. So this was the method the first time. The second time, the u will be 2x, and the dv will be e to the x dx, meaning that du is 2 dx, and v is equal to e to the x, meaning that this would be equal to x squared e to the x minus uv, or 2x times e to the x, minus the integral of, so we have du v, which is 2 e to the x dx, which is equal to x squared e to the x minus 2x e to the x minus the integral of 2 e to the x dx is just 2 e to the x plus c. So the answer to this problem is x squared times e to the x minus 2x e to the x minus 2 e to the x plus c. Today we learned about a common problem to use integration by parts on. Thank you for watching this video.